All right. Hi, you guys. Today we're looking at day 2, block 1 notes. We're focusing on complementary versus supplementary angles. And you will definitely want that definitions sheet, the conditional statements list that we introduced yesterday. So here's what it looks like. If you forgot, I would open it either as a separate tab or if you're writing it down on paper, whatever you need to do so that you can easily reference it, because we'll add a few things to that today as well. So going back to our notes here. So we have a warm up. I want you to try this warm up on your own based on what we did yesterday. So if you need to look back at those notes, definitely do so. So take a couple minutes, see if you can answer these questions. There's one down here as well. And then I'll go through the answers here. All right, here's what I had. There are definitely more correct answers than what I have written down. I just wrote some of the ones that I saw. The big ideas here are the notation, so making sure you have segments on top of segments, rays, lines, the triangle, and the angle symbols. All of the symbols really matter in geometry, so make sure you're being careful with that. And, there could be other segments. The line, for example, like you should not write line DB because there's no arrows there or anything like that. So just make sure you're careful of that. But you can check yours here. So looking at some new stuff today. So here's our two definitions. So remember, the star means that we're going to add it to that definition sheet. We have complementary and supplementary angles. Complementary angles are any two angles that add up to 90 degrees. And then supplementary add to 180 degrees. We'll add those to our sheets in a second. So one way people remember the difference, C comes first in the alphabet, so that's the smaller number. S comes later in the alphabet, that's the bigger number. Okay, one thing to help you. So you can see our example here, 30 plus 60. Yes, that equals 90 degrees. So this is a right angle. We can see the straight angle here. 110 plus 70 equals 180. So we would expect that the angles would add up to our straight angle measure. Okay, so let's go to the conditionals. Just good practice is writing our definitions as conditional statements. So we'll say if angles are complementary, then they sum to 90 degrees. Okay, so an example you can draw similar to the one that we had on the other page. Angle 1, angle 2. So angle 1 plus angle 2 equals 90. And then if angles are supplementary, then they sum to 90 degrees, or sorry, to 180 degrees. Same idea, I'm going to draw a straight angle because I like that example. 1, angle 2, angle 1 plus angle 2 equals 180 degrees. Pretty straightforward there. Right. So using that knowledge, we'll do some algebra here. We're looking for the measure of the smaller angle in this first example. So that symbol, the little box in the corner, tells me this bigger angle is a right angle, meaning these two guys are complementary. So I know that if I add 3x minus 15 plus 2x plus 10, they should equal 90 degrees. Okay. Now let's solve for x here. So I have 5x minus 5 equals 90 degrees. 5x equals 95. And x equals 19. Okay, so be careful though, this isn't our final answer because we're still looking for the smaller angle measure. This is just the x value. So I need this smaller angle. I'm just going to plug it into one of these equations. Let's start the first one. 2 times 19 plus 10. 38 plus 10. This guy is 48. 3 times 19 minus 15. 57 minus 15. This angle measure is 42. So this is our smaller angle. Okay. All right, so let's look at example 2. Similar idea. So whenever you have a straight angle split into multiple smaller angles, we can find x value knowing that they're all supplementary. Okay. There is one typo here. This Q, it should be an O. It should be SOR. But we know all three of these guys are supplementary. So we're going to add them all up. 5x plus 4 plus x minus 2 plus 3x plus 7 equals 180 degrees. So it can be more than two angles that are supplementary to each other, right, if they all add up to 180. Now we'll simplify here. Let's combine like terms. So 5 plus 1 plus 3, 9x. And then 4 minus 2 plus 7 is 9 equals 180. Now we're solving for x. So 9x equals 171. Divide by 9. X equals 19. Okay. Again, not done yet. We have to actually answer the question. We want the measure of angle SOR. So be careful here. Just take your time looking for the angle. Remember, the middle letter is the vertex. So start at S, travel to O, then up to R. So we're looking for this angle right here. Pretty easy. Angle SOR equals x minus 2. Plug in 19. So it's a 17-degree angle. All right. Why don't you guys try the next two on your own? So example 3 and example 4. See if you can do each of these. They're very similar to the two problems we just did, and then you'll be able to check your answers. All right. Here are my answers for example 3 and 4. Example 3, for the x value, I got 10 because these are complementary, so they equal 90 when we add them up. Angle MON is 24 degrees. Example 4, I get a Q value of 22. These angles are supplementary, so they equal 180. Angle ABD then equals 108. So again, feel free to pause if you want to look closer at that work. Moving on here, example 5. So it says, what can you conclude about angle ABC and angle EDC based on this picture? So let's find those angles. ABC, so that's this angle here. EDC, that's this angle out here. What can we conclude about them? Well, when I look at these two, so angle ABC and CBD, I'm going to say angle ABC plus angle CBD, those form a straight angle, so they equal 180 degrees. But I know the measure of CBD, it's 40. So I can solve there, meaning angle ABC equals 140. I can do the same thing on the other side. Angle EDC plus angle CDB also equals 180, so now I'm over here. Angle EDC plus 40 equals 180. So angle EDC also equals 140. That means angle ABC is congruent to angle EDC. Now we have a statement that we can use to describe situations like this, and we'll use it in a lot of our proofs. So we can say that supplements of congruent angles, so I'm using some symbols here to shorten it, congruent angles are congruent. So we'll use this in proof in a moment here. Supplements of congruent angles are congruent, right? So let's take a look at that. Let's actually write a proof. So we're going to work through this one together, the next two together. So we have our T-chart already drawn for us. The left side, we're going to label it statements. The right side will be our reasons. Every single time you write a proof, no matter what, the very first step is to copy whatever is given. Angle CBD is congruent to angle CDB, and you write given every time. That's it. Step one done. So this is true because it's given to us. It's told. Okay, I would also, after you write that, I would go to your picture and label it to help you remember that statement. So angle CBD is congruent to CDB. So these little arcs I'm drawing tell me that these two angles are congruent. Okay. Now I'm trying to show that angle ABC is the same as EDC. So that's the outside angles. ABC is out here. I'm going to draw two arcs for this one. And EDC, I'm going to draw two arcs again. So I use the given information and start to think about what I might know. I'm going to label these with some numbers to help when writing them so I don't always have to use three letters. So I'm going to call this one 1 and 2, 3, and 4. So I know that angles 1 and 2 equal 180. And I know angle 3 plus angle 4 equal 180. This is from the definition of straight angle. Okay, so that means that angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 4. This is from the definition of supplementary. So the reason we have that statement list is you can kind of refer back to it when you're writing your reasons. Most of our reasons will be something like the definition of this term, something like that, as we're writing. Okay, and if I know that those original angles are congruent, and I've stated which angles are supplementary, I can then state that angle 2 is congruent to angle 4. This is the same as angle ABC is congruent to angle EDC. As long as you have your picture clearly labeled, you can use numbers to shorten it a bit. And then I'll use the statement we wrote above to support this, the reason. The reason is supplements of, congruent angles are congruent. And there's my proof. Let's try one more together. Since we're just introducing proofs, it's a little bit tricky at first. So left side is statements. Right side is reasons. First step, always rewrite the given. ABD is right. Angle EBC is right. And that's given. So I'm going to start by labeling what I know, ABD. So ABD is right, so that's this one. EBC is also a right angle. That's this one. I'm going to label some of these, call this one 1, 2, and 3. So if 1 and 2 make up a right angle, I can say angle 1 is complementary to angle 2. And that's the definition of complementary because they add to 90 degrees. I could also say angle 2 is complementary to angle 3. Again, the definition of complementary. They add to 90. That was from our given. And then, if both of these are complementary, I might need another statement here. I know it seems silly. Angle 2 is congruent to angle 2. And this is from our reflexive property we talked about yesterday. Because my goal here is to show angle ABE, so that was angle 1, is congruent to angle CBD, which is angle 3. So I can say that angle 1 is congruent to angle 3. For the same reason that I used before, complements of congruent angles are congruent. And I'm done because the angle 2 is the congruent one. I will say that these two proofs are a little bit trickier, so don't be like super stressed out if you had trouble following, like if you're thinking, how would I know to come up with those? We'll practice more. You're going to get better at them. The more you do, the easier they get. That's really the only way to get better at proofs, is to do more of them. So don't be super stressed if it's a little tricky right now. We're just getting started with it.